it turns out that writing code that just stays within itself has a bit of a limited lifespan. Even last week, you were pulling information in from the user, the way that they were typing in a guess for the guessing game. So what we're going to do this week is look into a few of the different ways that you can get information out of other files or out of the internet, because that really is where programming becomes really interesting, because you can take some information from the outside that you don't know about and do something with it, discover something from it. So there is a file called IO examples, and IO is just the kind of abbreviation of the words input and output, and in it has a bunch of examples that all work. So you don't have to change this file to make yourself understand it, but you might want to have a fiddle around with it to see what the various things do as you play with them. It's in the course folder. There is one in your me folder, but it is a bit old, so have a look in the one in the course folder, and that will give you the most up to date. So let's have a look at this. So there's a bit of stuff in the doc string that explains a few little things that we'll get to as we come across them, but you just might want to refer back to it. And then there's a little link here to the Python docs on how to do this stuff. So that's worth having open while you're playing with this. Right, so we've seen functions like this, and what I'm going to do is basically step through this file and talk through what's going to happen while we're running it. So let's put a breakpoint on 42 and run it. We've got a local variable of my name because it's being called from here. The function is being called, and the argument that we've given it is Ben, and that comes in here. We could call it with anything we want. So this is just going to print this. So when we step over that line, if we look down in here in the terminal, it's printed Ben is cool, which is kind of not that useful. It's something we've done before. We've done lots of printing things just to see what's going on. But what if we wanted to save it into a file? And so there's two ways of doing this. There's the kind of obvious way, and then there's the safe and ultimately a bit easier way. Okay, so the obvious way is that we're going to open a file, write something to it, and then close it. The nice thing about this is it's very clear what's going on. It's very clear what's going on. The less nice thing about it is that when you're working with anything of any kind of real size, it's very easy to forget to close the file. And if you don't close the file, then Python doesn't guarantee that anything will actually be written to the file because of some like complicated operating system level buffer things. So when you're writing to a file with Python, Python doesn't write to the file. Python asks the operating system to write to the file. And if you don't close the file, the operating system doesn't kind of get around to it sometimes. It'll also mean that if you don't close the file, it might lock the file as open to that Python process, so you won't be able to open the file again. There's kind of a bunch of complicated and annoying things. So just remember that closing the file is important. So what we're going to do here is set a mode, and we're going to set the mode to be W for write, and then we're going to open the file, which is going to go to a folder called beniscool.txt, and then we're going to set the mode to be W, so write. So that's going to open a file and put us in the position. Now, something to remember here is that // means the next folder up. So we are currently in set 4. This will write to the next folder up, which is the sort of whole course folder. So just be aware of how you are addressing your files and where they're going to end up, because in the exercises some of the files have to be in specific places, and so the tests are going to be looking in that specific place, and if you're not there, then it won't be able to find the file and it won't be able to mark it. So just be aware of that, and we'll go over that in a minute again. Okay, so we open the file, and then we use the .write method, where we say this person is cool, and then we close it. And then what that has done now is, if we look in that folder, in the course folder, we can see here there is a, what are we looking for? beniscool.txt. So that's actually put it one up from the course folder, because that's my working folder. So if I look, let's say reveal in File Explorer, we go, that's course, and then we're 1161 here. You see now we have beniscool.txt in that position. So that's what up one from your working directory is, the working position. So we'll deal with that in a second. So let's try that again. So now the file name, the name is Ben, and the file path is Ben is cool, lol, you're joking. Now that doesn't look like a file extension, but actually a kind of secret is that the whole 3 or 4 letter file extension thing is just a convention. It doesn't matter what you make the file extension. The file extension is just there to help the operating system help you. So we can name our files basically anything we like. So we set the mode, open the file, write to the file, and then close the file. So that's great. It's done it. It's put that file in there, and then we can find that file here, and it's got the information that we wanted in there. So if we wanted to change that to be something else, it would also write that whatever something else is, which is actually what most file systems, or what most programs are doing when they save a file. They're just writing some information into a file. So that's good, but what if we want a way of stopping ourselves from making mistakes and leaving these things open? What is there a way we can manage that so that it stays open forever? And no, it doesn't stay open forever even, and there is. So what we would do there is we would use a with block. And so a with block looks like this, and it's a little bit more complicated. I've added in a bit more stuff. So here we're using the very minimum amount of information here. So we're saying where we want to put the path, put the file, and where we want to, how we want to address that file. Here I've added a couple more things. So let's break those things down. So we have a with block, which means all the stuff inside this block, use this idea that we're creating right now, and we're going to call that file history book. And then we've seen the open file path and mode path from just above, and we've added an explicit encoding. Now encodings are a kind of historical concept, I guess. Back in the day when computers weren't very powerful, you only had a certain number of characters that you were able to address, and that meant that different languages wanted to put different characters into that limited set. So if you are Chinese or Polish, then you probably wanted a more complicated character set than just the standard 26 Latin letters. That is largely not really a problem anymore now that we have Unicode and we have a very, very large character space. And so what we could do here is add in a bunch of emojis, and that would work fine because we're dealing with UTF-8 characters or Unicode characters. And so that means that if we want to put in a bunch of symbols, we can also do that, because the standard character encoding doesn't always default to that. That's kind of dependent on your operating system, so we have to be a bit careful there, particularly if you're not using kind of basic unaccented letters. So let's put in a breakpoint here and rerun this so that we get it with those extra characters. Right. So again, we're going to set the mode to W for write, and the with block will open that file and keep it managed. And so as we jump into the with block, now we have this file called history book, and we're going to write to it, and we're going to write this stuff. Now, when I step over that, it will come out of the with block and it will close it. And so that gives you a much more implicit way of managing your files, which is much less likely for you to make mistakes. So let's step over that. And so if we go back and look for the benniscool.txt file, and we open that, we see it's got all the emojis inside it. So that's cool. Emojis and special characters and all that sort of stuff. So it's always good to put in that encoding UTF-8 kind of as a default, because if it doesn't work, then it's much more likely that the problem will be that you're not encoding as UTF-8 than you are. It's very unusual to find files that are not encoded like that. Alright, so what that is basically saying is that we can open a file and we can write something to it. We can write any characters we like. We can draw big pictures with just emojis as the pixels, or we can do whatever we want. But what that gives us is the ability to save our data that we've generated with our Python program, which is cool. But if we want to get something into the computer, then we need to be able to read files. And so if we want to read something, then it's almost exactly the same, except we set our mode to R for read, and R is actually the default. So if you ever see something that says just open file path and then it closes the brackets, then it's implicitly saying read. So what we get here is we again open the file, set the encoding, and then we can read that file. And so read reads the whole file in one go. So we can see over here that our response here is what we've pulled out of that file. Now we've got the emoji in there because we have encoded it as UTF-8, because it would fail if we didn't. It would have just come in as complete garbage if we just read it without that. And so when we step over that line, it will print this. Now the /n/t or \n/t is they're called escape characters. So the whole of that pair, the slash and the n and the slash and the t, that is a new line and a tab. And we can see this is on a new line and it's tabbed in by a bunch. Now for some reason when I say /t it puts in 8 spaces rather than 4, but that's however they do it. And so that now allows us to read that information and then write it again. So we could do something incredibly useless here by saying open a file, reverse the text, write it into a different file if we wanted. And that is a surprisingly important idea in computing, because that basically gives you the ability to open a file, manipulate it, write it back again, which is one of the foundation concepts of a Turing machine. Alright, so that's all very well if we want to load in text files, but most things we're going to come across these days are going to be encoded in some kind of what we call machine readable format. Now, machine readable is a bit of a funny one because machines don't care about being human readable, and it's difficult to tell whether something like JSON, which is JavaScript object notation, is machine readable or human readable, but it's definitely structured. So we can think about JSON as a structured type of file, and if we're going to read it in or write to it, we need to be able to structure it in a consistent way. So this is about how we're going to write to a JSON file. Now, I've got a dictionary here which contains the message that we're going to put into the capsule, and then we're going to call this function. We're going to give it that data, because that data is what we're passing in, and we're going to save it in the file under the patio.json. Okay, so let's have a look at this file. So we're going to put it in a try except block, because sometimes these things break. Not everything can be encoded as JSON straightforwardly, so you need to work out whether that's possible. So it's good to be a bit safe here. And so the JSON module gives us a method called dumps, which is dump string. So there's something for your kids to find is the argument that we just passed in, which is the data, so all of this stuff. And so when we step over that, we'll see the dumped thing here, which is a string representation of that data, which is what we're going to write into the JSON file. So we set the mode to write, then another with block to manage the file, and then we write to that file. And now we're outside that, we know that it's closed, and so we can look under the patio and see that JSON. Now, because we didn't give it any formatting instructions, it's not formatted, which is probably good, because it means that it's uses up less space. But if we wanted to format it, what's the problem here? Oh. Yeah, it doesn't want to. Anyway, if we wanted to format it, there are ways around that. So if you want to do that, then come and ask me. Alright, so now we can return true, and we're all good. So what that has done now is created that file. It's structured data, and if we want to re-access that, we can use the dig up capsule. So when we call the dig up capsule, we give it the file path, which is the same as the one we just used before, and then let's see what happens here. So set the mode to read, R for read, and then we open the file and we use the JSON load. So JSON has dumps and dump and load and loads, and it took me ages to figure out that the S in both of those meant load string and dump string rather than load and dump. So what this is doing is this is loading a file. So time capsule is not the contents of the file, it's actually the file itself. It's an IO wrapper. So here we can see this is an IO text wrapper, which is a bit of a weird idea, but what it means is that JSON.load knows how to handle a whole file rather than it having to go via a string before it gets to you. So you can do the same thing with dump, we just didn't. So we're saying load the contents of that, convert it into JSON, and then store it in the variable named contents. So if we step over that, we can see that there's a contents thing, and it's actually exactly the same as when we put it in. So that's great. Now, the rest of this is just a bit of kind of fancy safety stuff, defensive programming we call it. So let's have a look at this. So if, now, key in contents for key in keys needed, let's see what that gives us if we put it into the debug console as a list comprehension. So it's asking for 3 keys, greeting, year, and fact. And it's saying, is the key in that dictionary for each key in all the keys needed? So it's just asking, does this dictionary have all the keys that we want? And then all takes a list of booleans, so let's say true, true, and returns true only if all of them are true. So if this one is false, then it will return false. So it's saying if all of these things are here, do this stuff. Otherwise, do that. And now, if something fails, do the other thing. So this is kind of a lot of real life programming is handling these kinds of weird situations that happen, the edge cases. So the obvious bit that runs down the middle is pretty straightforward, and then handling the weird and tricky bits is difficult. Now, we kind of know that this is going to work because we've literally just made it. But here we can see, okay, we've got greeting, we've got location, we've got year. But here, we're imagining ourselves 100 years into the future, and so we don't necessarily know that the format of the incoming data is going to be the same as the one we're expecting. So we're checking to see if it's going to work. So we've got a template, which we've seen a little bit before, and we're going to use the dot format thing, which I've been pushing us towards F strings a lot in the last couple of weeks, but sometimes you do want to use the dot format method of doing templating because it allows you to do stuff like this. And what that does is, let's do that in the debug console again. I'll run that line first. Alright, so what that does is gives you the contents. Contents is what's in the thing, and it expands it out into a key value pair set. Now this is relatively unusual to use. It's a bit of a pro move, but the reason I'm showing you is that when you see it and you see the 2 stars, it's unlikely that you will have to use this as a thing anytime soon, but you will probably see it in other people's code. So when you see it in other people's code, don't freak out. It just means expand it out to a series of key value pairs. Okay, then we return true, and we're all good. So if we go back to our terminal, it says it's got a greeting, and then it's got a fact, and then it prints the fact, and then we're done. And so that's more or less everything you need to know about doing file I/O.